So now we're going to practice some word problems using sine and cosine, their graphs, as well as these transformations coming through so that we can graph them without a calculator. But then we'll also talk about how a calculator can help us find solutions, specifically to questions where it could be difficult algebraically to solve. Okay, so this first example here, they're giving us the function, and actually, sorry, I need a little correction there. That variable there should be t, not x. So this function's mapping sales, and sales in millions of dollars, and it's mapping based on time t, where t is representing the month of the year. So t equals 1 represents January, and 2 is February, until we get to 12 for December. Alright, so reading this function, let's talk about the transformations that we're seeing here. So we have an amplitude of 6.25. For the period of the graph, we would be taking 2 pi divided by that pi over 6, which if we multiply the numerator and denominator by 6, we would have 12 pi over pi. So, sorry, just to add that in, it's like it went times 6 times 6, and those pi's would cancel out, so we have 12. Which makes sense if we're mapping kind of one full year, like we're going January to December, so that makes sense that it would start repeating after 12, because then we would just be into the next year where things should be behaving the same. T plus 3 is a phase shift, and it's going to be a shift to the left, 3 units, and then 8.1 is our midline. Alright, and then we're dealing with sine, which, just to refresh our memory, starts at the origin, goes up, down, and back to the midline. So we can use those kind of key points to help us out. Alright, let's make our axes. So this should be pretty much all in the first quadrant, and that's going to typically happen with our word problems. Rarely will we be dealing with negative numbers. And for the y-axis, let's take a look at our midline and amplitude. So with that, I could think about the range of this graph. So the domain's all real numbers, even though we'll kind of talk about how that adjusts for application. But for the range, we should have a minimum and maximum value. And it's coming from, we have our midline, and then we go above it and below it. So our lower bound should be that midline minus 6.25. And then the maximum should be 8.1 plus 6.25. So that should give us this range from 1.85 up to 14.35. Let's see, I want to see up to, for my sales, up to 15. So maybe I'll scale this by 2s. So 2, 4, 6, 8, 10, 12, 14, 16. I could already kind of draw the bound, so the midline is at about 8, a little above really, but I'll just drop close by. And then with the amplitude, the largest value should be 14.35. Maybe about there. And then for the lowest value, 1.85, so a little less than 2. So that gives me some kind of restrictions to work with for our graph. And then for the period, well, we really want to see the mapping for one full year, so I just need to go up to 12. So I'm going to just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that axis is for time. Alright, so now we're working with sine, but we also have this phase shift to the left of 3. So, let me draw some points of where sine would be initially. So this is without the phase shift. We would start here. We would be ending at 12, halfway in between. So at 6, we would be at the midline. And And let's see, halfway between 0 and 6, we would be at the maximum. Halfway between 6 and 12, we would be at the minimum. So that's where we would be without the phase shift. But what we're going to do is pick this up and move it to the left 3 units. I'm going to put one more off to the right-hand side here, back up at that maximum. Alright, so phase shift to the left. So we're going to take each of these points and move them to the left 3 spots. Now that first point goes kind of off the page, so I'm going to leave that. But our maximum point here will go 1, 2, 3. So we're going to have our first coordinate up there. And to the left 3, to the left 3, to the left 3, to the left 3. So I'm going to get rid of those open circles. We're done with those. They just kind of help us see our starting point. And we're moving it. So our graph is going to look like this. So from December and back. And what I'm going to do is I'm going to actually stop this graph at January. Because 0 technically isn't part of this. In terms of months, we would be starting at January. So that's just a little bit less. So I'm going to start that there. And that's just interpreting kind of the setup of this problem and how they're describing how the t-axis is behaving. So that means now we can see January to December. So just kind of keeping that in mind. So let's check this out in Desmos and see how this translates. So typing it in, we would have 6.25 sine of, and then pi over 6. And then we'll have parentheses, x plus 3, parentheses, parentheses, plus 8.1. So here I can see how we're starting up at that maximum. There's that 14.35, decreasing down, minimum, 1.85, back up to that maximum of 12. Alright, so now let's answer some questions. In what month are sales highest? So basically, when are we reaching that maximum? And what we can see is that that was happening in month 12, which is December. Now, how we can also see this on Desmos is that often you can see these kind of gray points coming through happening at the minimum and maximum values. So if you weren't sure, you could click on that point and that would show you the coordinates. So we could see that t equals 12 there. We can also see our value of 14.35, which would answer part B. What is the manufacturer's highest monthly sales? So that would be $14.35 million. How we also found that was by taking the midline plus the amplitude, gave us that value. So you can see it on the graph right there. In what month are sales the lowest? So when are we reaching that minimum value? And we can see that is happening in June. So in t equals 6. And what is the manufacturer's lowest sales? So we could get that from the graph, or that 8.1 minus 6.25, which was 1.85. And that would be $1 million. Alright, so this is a case where they give us the function, and we just need to use the transformations to get a graph going, and then with that we can answer. But let's look at a case where all they give us are words. And how do we take those words and turn that into a sine or cosine function, and then along with our transformations? So, the height in centimeters of the tip of the minute hand on a vertical clock face is a function h of t of time. So what we're going to be seeing here, just to get a picture going, because I'm quite visual, is we're going to have a clock. And we're going to have the ground. And on that clock, we have a minute hand. And that minute hand goes around the clock. But at any time, so we're going to map some time that's passing, but what we're going to be looking at is the height of the tip of that minute hand. hand. So we want to see what is the height from the tip of the minute hand to the ground. That's what we're mapping here. So as you can imagine, as it goes down, that height gets smaller, smaller, and then it will reach a minimum height, and then it will start getting higher and higher and higher, and then it reaches a maximum height. So the minute hand is 15 centimeters long. Let's go ahead and put that in there. That's 15 centimeters. And the middle of the clock face is 185 centimeters above the ground. What we're doing is we're saying right here, so the middle, so where the center of the clock face is, to the ground is 185. Alright. And skip the graph and find the equation. Okay, so I'm going to go ahead and make this graph in our first quadrant, since these should all be positive. So we're looking at h of t, so we're going to have mapping the height and the time. Now, from this picture, I can get an idea of the amplitude and midline, which will help me set up my y-axis. So if I think in terms of like maximum, minimum, and then this is actually our midline right here. Our midline is going to be 185, because that's going to be the value we kind of return to. So then it's going to get lower and lower and lower, return to that value, higher, 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 return to that value. So our midline is going to be that 185, or rather than y, this is h in this case. Then the amplitude, well, remember that's the radius of our circle. That would be 15. But if you wanted kind of proof of that in terms of our maximum height and minimum height that we're seeing, our maximum height is going to be that 185 plus 15. So if we're at 185 here, getting to the maximum height, we would add on 15. So with that, let's see, what does that end up being? 200. And then our minimum height would be the subtraction of that, because we would have our total 185, but then I'd want to take out the radius of the circle, which should be 170. So with that, I now have an idea of the values for my y-axis or my h-axis. So the amplitude is 15, because we're going to kind of keep returning to this 185, but then go up to 200, go down to 170. So visually, what that means for our graph, let's see, I'm going to need to see between 170 and 200. I'm going to go ahead and skip ahead to 160 here, and then go by tens. So 160, let me jump. 170, 180, 190, 200. So this right here is a line break. It lets us skip ahead because I don't really need to see between 0 and 200. The idea being like all this space underneath the clock, nothing's happening down there. So we can skip over those heights that are 0 to 170. All the interesting stuff is happening up here between 170 and 200. That's where the height is really changing. And what we just said is we now have our midline, which is that 185. And then we're going to go 15 centimeters above that to get to the peak of 200. And 15 centimeters below that to get to our minimum value. So that's how this kind of height to the middle of the clock gives us our midline, and then the radius, or rather the length of that minute hand, is telling us how far above and below that midline we're going. Alright, so basically we can start time wherever we want to. It makes most sense to start the clock at the top, just to start at 0. So what I'm going to do is I'm going to have my clock start here, which means I'm going to start at the maximum height. So let's see, for t, and let's just track some minutes here. How about we'll go in 5s, increments of 5 minutes. And you can see a full hour. Alright, and I'm saying I want to start up here at 200. So that would mean when time is 0, we're at 0 minutes. That makes the most sense. And then when we get to 15 minutes, we should be at the midline. Alright, based on the clock, let me just draw a clock over here. If we're at 15 minutes, we would be right there. And then at 30 minutes, we would be at the minimum height. And at 45 minutes, we would be back to the midline. And at 60 minutes, we'd be back to the top. And that way we can see this height of the tip of the minute hand across a single hour. And you can imagine it would just repeat again and again on forever. Alright, so there's a sketch of our function, but now let's actually find the function. So we already talked about the amplitude of 15. We have that midline, which is y equals 185, or h. We can see how long one period is, which it's those 60 minutes. Now, if the period is 60, let's go ahead and solve for b. So 60 equals 2 pi over b, which means b is equal to 2 pi over 60, which would be pi over 30. And then in terms of phase shift, well, this is set up so nicely for our cosine function, starting at the peak, dipping down, going back to the peak. So I'm just going to use cosine, so with that there's no phase shift. So with that, h of t, I'll have my amplitude of 15, I'll have a cosine function, b is pi over 30, times our variable t, close those parentheses since there's no phase shift, and then get up to that midline of 185. Then let's check our answer. What I'm going to do is kind of keep in mind the axes I set up there, because I want to see something similar. So, we're going to plug in 15 cosine of pi over 30 with our variable, and when your variable's t in Desmos, always type it in as x, and that's true of calculators as well, and then plus 185. So with that, we're way off the screen here. So what I'm going to do is go ahead and jump up, let's see, the x-axis. We want to see at least up to 60, so I'm going to go 65. And then for the y-axis, I'm going to jump up to that 150, and I want to see, let's go 210. So we can see our cosine function. Let's see some key values, 0 to 100. What, at 30 minutes, we said we were at our minimum. Sorry, 30 is showing up at the bottom here. It's just slightly off screen. But there's our 3170. And back to that maximum of 200. So that's behaving exactly how we want it. So those are the two types of cases with our applications. Sometimes they give you the function and you just need to interpret it. Or they'll give you this block of text, and what could really help is to draw a picture. But there should be this idea of middle, and then with an amplitude, you're thinking about going up to a maximum and minimum value. And then there should be this period in terms of when does the behavior start repeating with itself. Which a lot of these cases, sine and cosine are coming from circles. So when you're relating to circles, it's going to be this idea of completing a full revolution. Or in terms of months, the cycle begins with a new year. So thinking about how long does it take for this complete cycle